So, hi all. My name is Surabhi Navyasri, and today I'll be talking about my project called Segmentation and Estimation of the Swim Pose. So, this project is about using AI to understand the swimming techniques by analyzing the videos. And coming to the project overview, in swimming, posture and stroke form are very important, but analyzing videos manually is slow and not always accurate, especially underwater. So here I have used AI to solve this with SAM for segmentation and pose model to track the swimmer movements. So coming to the introduction, underwater footage is hard to analyze as we know. So there is a many reasons like distortion, bubbles, and poor visibility underwater. So to deal with this, I have used SAM to segment the swimmer and the pose model like YOLO V7 or YOLO V8. We can use either of it to estimate the body joints. And objective of this project is to segment swimmers from underwater videos and estimate the body poses, showing the visual results and the joint coordinates, which can help in the future research in stroke analysis and the training. So, in this project, segmentation methodology is that I took 20 keyframes from the swimming videos and passed them into the SAM. And SAM removed the background and gave me a clear image of just the swimmer with no distortion, no pool ties, or noise in the video. I'll I'll show you the code for the for which I have extracted 20 frames. So here you can see this is the code for extracting the frames from the video. So here you can see that I have successfully extracted the 20 evenly spaced frames from the video. This video is for like detecting the swimmer and calculating their confidence. That is, you can see 0.44 or 0.33. And coming to the pose estimation methodology, I have tested a few poses models and I chose YOLO because it was fast and worked well with the segmented images. And it also helped me to identify the joint points like elbows, knees, and shoulders. So output for this both I'll show at the end of the video for the video output. So this is here are the output for the frames. So here we start with the original underwater frames, which you can see here, and it contains the swimmer along with the various visual distraction like the pool tiles, lane markers, and the bubbles. And next we will apply YOLO, an object detection model, to draw the boundary box around the swimmer, which helps to localize the region of interest. Then we will use this bounding box as an input to the SAM, which generates a precise mask that isolates the swimmer at the pixel level, removing everything else in the frame. And finally, we will place the swimmer on the clean white background, giving us a shape and noise-free image. And this processed image is ideal for the next step where we will apply the pose estimation to detect the body joints and analyze the swimming posture with the high accuracy. This is the output one and this is the output two for different angle. And coming to the model comparison, I have compared MoveNet, Open Pose, and YOLO. And MoveNet is fast, but it's not that accurate. And Open Pose is also accurate, but needed a clean images. And at last, the YOLO is the best balance, and I have choose YOLO for the best accurate results. And coming to the model output, which is the segmentation output, this slide demonstrates how the bounding box and the SAM model work together as a pipeline. So first we have use and object detection model. In this case, YOLO is to identify the swimmer in the frame, and YOLO draws a bounding box around the swimmer, giving us a rough region of interest. Next, this bounding box is passed through the segment anything model, that is SAM, which uses is as a prompt to generate the high precision mask of the just the swimmer. So the result is a cleanly segmented image where all the background elements like the pool floor bubbles and the lane lines are removed. By isolating the swimmer in this way, we can make it much easier to analyze the body movements and the posture because there is no visual noise interfacing with the pose estimation model. And this image shows the first step of the pipeline, which is the object detection using the YOLO model. As you can see, the YOLO successfully detects the person with the confidence score of 0.82 and draws a blue bounding box. Here, Also the YOLO mistakenly detects another object, the bowl background with called the boat with the confidence of 0.33. And this highlights one of the challenges in working with underwater environments where lightning and distortion can confuse the model. Despite that, the bounding box on the swimmer is accurate enough to be used as the input of this SAM segmentation step, where we'll generate more precise mask that isolates the swimmer from the background. So this image represents how we localize the swimmer before applying to the segmentation. And coming to the this slide, the pose estimation applied to a clean segmented image of the swimmer. Here you can see with the white background. The swimmer is fully isolated on the white background, and the model detects the swimmer as a person indicated by the blue bounding box. Within the box, we have used the pose estimation model to identify the key body joints represented by the orange dots. This output I'll show at the end of this video um, in the form of video output. So at coming to the conclusion of this project is that I have used the SAM to segment the swimmers and YOLO to estimate the pose, and it worked well on the underwater video and gave me the clean outputs. So maybe in the future this can help coaches to real-time feedback, give the real-time feedback to the swimmer. So coming to the output, I'll show you the video output. So this is the first pose output. Here you can see the orange dots which are joining the join points. And another video for a different pose. It's not that clear, but you can see the body joints. It's because of the distortion in the video. So that's all about this project. Thank you.